Welcome to another session of Calculus, Part 2. We discuss gradient of a curve. Look at the graph. We are going to understand average gradient of a curve. We have 2 points, P and Q on the curve. PQ is a secant, the average gradient of the function f between x equal to a and x equal to b is the gradient of the line joining P and Q. And we know how to calculate the gradient of a line when we have 2 points. Look at the graph. We have 2 points. P is 1, 2 and Q 2, 5. And we know how to calculate the gradient of PQ using our gradient formula, y2 minus y1 over x2 minus x1. Here it is 5 minus 2 over 2 minus 1 gives us 3. So the gradient of PQ is 3. And we say the average gradient of the graph of f of x between x equal to 1 and x equal to 2 is 3. Here is a parabola. Find the average gradient of the graph of fx equal to x square minus 4 between x equal to minus 1 and x equal to 3. So we can see the line PQ, but we do not know the y values. The x coordinate of P is minus 1. Now what we do? We substitute minus 1 into the function. So f of minus 1, x is replaced by minus 1, equal to minus 1 square minus 4, and we get minus 3. So we got the 2 coordinates of the point P, that is minus 1, minus 3. Similarly, we are going to calculate the coordinates of Q. We substitute x equal to 3 and then we get 5. So the coordinates of Q are 3, 5. Now the gradient of PQ, the gradient of a straight line. We all know the formula, y2 minus y1 over x2 minus x1. We substitute these values, 5 minus of minus 3, 3 minus minus 1, we get 2. So the gradient of PQ is equal to 2. And we say the average gradient of the graph of fx between x equal to minus 1 and x equal to 3 is equal to 2. That is the average gradient of the graph of fx. Again we come to the same graph. PQ is a secant line, and look at the movement of the line PQ. As Q moves closer and closer to P, then Q and P coincide at one point. Now PQ is a tangent. How to find the gradient of this tangent now? We have only 1 point. So now, how to find the gradient of this tangent? Here comes the calculus. The concept of limit is applied here to calculate the gradient of the tangent. So, our intention is to calculate the gradient of the tangent. We come to a general formula for the average gradient here. Look at the points. The x-coordinate of P is x. Therefore, the corresponding y-coordinate in general should be f of x. And the x-coordinate of Q, look at the graph, it is x plus h. Therefore, the corresponding y-coordinate of Q must be f of x plus h. So we start calculating the average gradient using the x coordinates and y coordinates of P and Q. And we know that average gradient is y2 minus y1, that is f of x plus h minus f of x over x2 minus x1, that is x plus h minus x. Now we simplify the denominator, x and minus x will be cancelled and we get equal to f of x plus h minus f of x over h. So we continue. Our intention is to calculate the gradient of the tangent. PQ is there. Now, as Q moves closer and closer to P, let us look at that. Moving closer, look at the difference. The h is becoming smaller. Again, now the line is a tangent. What happens? The difference h is approaching the 0. So that is what we notice here. The difference between the x coordinates, that is h, becomes smaller and smaller, or we say approaching 0. Now the gradient of the tangent at the point P. We know the concept of limit h approaches 0. So here is our use of calculus, use of limit, applying limit. So we get the gradient of the tangent at 1 point. This gradient of the tangent at any point is the gradient of the curve at any point. What is that? Equal to limit h approaches 0, f of x plus h minus f of x over h. And that is the gradient of the curve. In notation, f dash x or f prime x is used to represent the gradient of fx. So we say f dash x equal to limit f of x plus h minus f of x over h. H tends to 0 is the definition of the gradient of the curve at any point. Or we can say f dash x is the derivative of the function fx. So derivative and gradient, same thing. Now, finally, we look at this cubic graph. We can see so many tangents everywhere on the graph. F dash A is the gradient of the tangent at x equal to A, as well as the gradient of the curve itself at x equal to A. So if we can get the gradient of the tangent, that itself is the gradient of the curve at a particular point. Therefore, f dash A is the derivative of the function fx at x equal to. So we did understand the gradient of the curve. Gradient of the curve means the derivative of the function. In calculus, we talk about gradient. Calculus is all about gradient. So that is the part 2 of calculus. We discussed the gradient of a curve. Gradient of a curve, derivative of a function. Hope you understood very clearly. Please share with your friends so that all of them will understand the topic calculus and they learn and revise and score good marks in calculus. Thank you.